Hi guys, so we're going to have a look today at how we can move on from what we were looking at in the last lesson, where we'd got graphs drawn for straight lines and we were looking at where they crossed to get this point of intersection. And we're going to move on to look at how we can use our skills in solving equations that we got from a couple of weeks ago to be absolutely certain that we've got the right answer on these ones. Let me just start off with a bit of an example. So on the graph we see here on the right hand side, I've got the blue graph, which is y equals x plus 1. So the gradient there is 1. Okay, for every run of 1, I get a rise of 1. And if I just bring in my laser pointer, we can see if I'm down here, if I go across 1, run 1, I get a rise of 1. Run 1, rise of 1, run 1, rise of 1. So that is because of that invisible 1 that's in front of the x. 1 times x. 1 is the gradient. 1 is also the intercept because we've got the plus 1 on the end there. So there's our intercept. It's going through there. So we know it's going up 1 for every 1 it goes across. And we get a couple of points. We get the graph looking like that. The red graph is y equals 3x plus 1. So the gradient here is steeper than the other one. The gradient here is 3. So that's why our line looks steeper. For every run of 1, we get a rise of 3. Okay, and we can see that happening. And our intercept is minus 4. Goes through minus 4 here on the y-axis. So for every 1 it moves across from there, a run of 1, a rise of 3. Run of 1, rise of 3. Run of 1, rise of 3. So in the last lesson, we were looking at the points of intersection, where two straight line graphs might meet. And we can see that's happening in here. The slight problem we've got with this one, though, is, okay, we might think that's about halfway along between 2 and 3, but might it be 2.4? Might it be 2.6? And again, we might think something similar here. Somewhere between 3 and 4 they're crossing, but can I be sure exactly what that value is? Well, as it stands at the minute, no, I can't. All right. Might depend on a number of things, how accurately I've drawn my graph, how big my graph is, whether my ruler's moved about a little bit while I've been drawing it. So any number of things could mean I get this slightly out, and it's difficult to see. And this is where algebra comes in to save us again, like it always does. Algebra's always coming in to save the day, isn't it? So we can have a look at using our skills on solving equations to help us work out exactly where these two graphs must meet. And all we do, I'm going to change now just to a pen. All we do is we write down the equations of both equal to each other. Because they're both saying y equals, actually I will go back to my pointer, because we're saying y equals x plus 1 here, and we're saying y equals 3x plus 4 here, then these are both giving us y where the graphs cross at the point of intersection. So if they're giving us the same y value, that must mean that x plus 1 is the same as 3x minus 4 at the point where they cross. So that means I can start off with a bit of an equation. I can just now write down the fact that the y value given by the first equation must equal the y value given by the second equation. Okay, so I've got my x plus 1 equals 3x minus 4. Now, if we were solving this equation, we know we would do a step where we think about subtracting this x away. Remember, we've got x's on both sides. If we've got x's on both sides, we think about getting rid of the smallest number of x's. We've got 1x here, we've got 3x here, so we're going to get rid of that 1x. To get rid of it means taking it away. We've got to then take away from both sides. So if I bring my pen back, I'm just going to take away an x. Okay, take away an x from the left-hand side, I am just left with 1. If I take away an x from the right-hand side to keep it balanced, I am left with 2 lots of x. I had 3 to start with, I've just taken one of them away, and a minus 4. I'm just going to swap this round so it reads the other way. I'm saying two things are equal to each other. Well, I know I can just swap it round. The two things are still equal to each other. That can sometimes be a nice step to do, because we usually like having the x's on the left-hand side if we can get them there. Two things are equal to each other. Well, all I'm doing here is writing them the other way around. Okay? They're still equal to each other, aren't they? My next step here would be to think about the 2x minus 4, what's happened last. I'm trying to get back to the x, remember. What's happened last is I subtracted 4, so I'm going to need to add 4. That will take me to 2x on the left-hand side, back to the 2x, and on the right-hand side, it's going to take me to 1 plus the 4 when I've added that on is 5. This is 2 times x. Remember, there's a kind of invisible little times sign in there. Okay, 2 times x. We need to get back just to what x is. And like we did the opposite, subtracting 4 here, so made us do a plus 4. Timesing by 2 here makes me do a divide by 2. 2 lots of x is 5. I can divide by 2 to say what x is. Dividing by 2 on the other side, it's 5 divided by 2. I could leave that as a fraction if I wanted to, or I could think about it a little bit or use my calculator and say that's 2.5. So it actually was halfway between the 2 and the 3, like we said it might have been. We couldn't have been absolutely sure, but it actually was exactly halfway between them. But all we've done at the minute is work out what the x coordinate is here. We also need to know the y coordinate. Now I suspect it might be 3.5, but how can I be sure now what it actually is? Well, remember, I have got 2 equations. I've got an equation that says y is x plus 1, and I've got an equation that says y equals 3x minus 4, and they are both equal at this point. So I can use either of these equations to work out what the y value is here. Yeah, because my point is on the red line, so I could use this one, but my point is also on the blue line, so I could use this one. Actually, the blue equation is easier to use. It's simpler. It says just take the x value and add 1. So I'm just going to use that equation. Okay, I'm just going to use that equation. And it says that my y value is x plus 1. But now I know what my x value is at the point. I've just worked it out on the line above. X is 2.5. So I can just say that my y value is 2.5 plus 1, which is 3.5. Now, if I'm asked to say the coordinates of where the graphs have their point of intersection, I would put the x coordinate first and say they cross at 2.5, comma 3.5, comma always for coordinates, and always remember you have a bracket at the front and a bracket at the end. And that is my point of intersection. Now, we said before with equations, we can check our answers, and we can. We can check our answers here as well. Because we decided to use this equation, we didn't use this one, the 3x minus 4. What would have happened if we'd done that? Hopefully, I'm still going to get 3.5. So what would I have had to do here? I'd have had to do y is 3x minus 4. So I would do 3 times my 2.5, and then subtract a 4. Yeah, because I know that my x was 2.5. That's in no doubt. Subtract a 4. 3 times 2.5, you could use your calculator for it, or if you could just see that that's going to be 7.5. And 7.5, take away the 4, is 3.5. So I've just checked. I've been absolutely certain. I know I got the right answer. Okay, so this method, let's just recap it. What do we start by doing? We start just by writing the x parts of the equation equal to each other, because the other bits say y, and the y values we know are the same. So this bit must equal this bit, and we can go through and work out then what our x value is, just from doing the same sorts of things we normally do with equations. And once we've got our x value, we could use either of these equations to work out the y value. And I've done it in both just to check I get the same answer, and then I remember to give my answer as a point coordinates. So I've got my x value and my y value. Okay, so that's the first example. Just spend a minute, just make sure you're happy with that one. You can see what we've done. So we're going to try another one. Okay, again, we've got y equals 2x minus 1. We've got y equals half x plus 2. We've got a red line. We've got a blue line. We've got a point where they cross. I think I can see this one. Actually, this is one that was from the exercises that you've been looking at earlier. I think I can see that it's 2, 3. But can we show it using algebra? Well, we should be able to, because the algebra should work for everything. That's the advantage, okay? whether we've drawn the graph accurately or not, the algebra will always work. So in this case, I'm going to be able to say that the two expressions for y must be equal to each other, just as we did before, because where they're crossing, the y values have to be the same. The x values are the same, the y values are the same. So we end up with that to start with. Okay, the half x plus 2 is the 2x minus 1. I really tend not to like, and I think most people don't really like it when we start getting fractions involved with equations. It makes our life very difficult, or it can make our life very difficult. Fractions, negatives always seem to make life more difficult. So what I'm going to do, I recommend you do this whenever you see a fraction, is to times by the denominator before you start. That will get rid of the fraction, because when I do 2 times the half here, that just gives me 1. 2 times half x is going to give me x. Yeah, 2 lots of a half of x is going to give me x. 2 lots of the 2 will give me 4. Doing the same on the other side, 2 lots of 2x will give me 4x, and 2 lots of the minus 1 will give me minus 2. Well, again, I'm on my way, aren't I? I've got x's on both sides. There are things that I can deal with, and it's now very similar to the last question. X here, 4x here. The smallest number of x's is this x, so we're just going to get rid of that one. To get rid of it, we just need to take it away from that side. We take it away, we get left with 4. Take it away from the other side where we had 4x's, that's now going to be 3x, and that's going to be minus 2. Again, I'm going to do the trick where I just swap it round, because I like having my x's on the left-hand side. All right, if we've got 2 things that are equal to each other, we can swap the order around. That's absolutely fine. And now, working back. Getting the x on its own, what's the last thing that we did? We did the subtract 2. So we've got to undo that with an add 2. 3x then, after we've added the 2 there, to reverse the minus 2. 4 plus 2 on the other side is 6. This is 3 times x, remember? So because it's times by 3, to get back to x, I'm going to need to divide by 3, and I do get x is 2, which is what we expected from looking at the graph. We expected we would get x is 2 from here, and actually that is correct. All right, the algebra is showing us that's correct. How do we get the y value? We look at the 2 equations. We now know what x is. We've got this one, or we've got this one. Probably we think this one's easier because it doesn't have the fraction in it. So we'll work with that one to start with. So I'll say, I now know that y on the blue line is 2x minus 1. I know my x value is 2. So that's 2 times 2 minus 1, which is 3. Again, what we saw from the graph. Back over here, it was crossing at 3. Yeah, so our graph was well drawn. We've shown using algebra this is exactly the answer. So our point would be 2, 3 with the brackets. How can we check? Like we did last time, we can use the other equation. What happens if I put the x value into the other equation? So I'm doing half of x and then adding 2. Okay, so I've got to do half of 2 and then add 2. Remember, of always means times. Half of 2, add 2. Half of 2 is 1, add 2 is also 3. We got the right answer. Okay, so just give that a second, maybe pause it, just check you're happy about what we've done there. Just the same, we've started with writing these 2 expressions for y equal to each other because they must be where they cross. And then we follow through our algebra that we've done before. Okay, let's have a look at a question that's in a bit more context. So this is the kind of thing that really the internals really focus on, don't they? You're not just going to get something that says, here's 2 equations and work with that. You're going to get something in a bit of a context. So here we've got Pete's having a sunflower growing competition. The graph below shows the height of his sunflower over time, and we can see he's measured the time in days, and he's plotted his straight line graph. He's got the height of the sunflower against the time in days. Give the equation for the height of the sunflower in terms of the time from planting it. Okay, so what I might do first of all is just say I'm going to use the letter H to stand for the height, and I'm going to use the letter T to stand for the time in days. All right, if you were doing this in the internal, you'd write down H as a sentence. H is going to stand for the height in centimeters, and T is going to stand for the time in days. Now, what can we see? What do we know about equations of straight lines? We know the gradient and the intercept gives us the equation. But here's my intercept. That's quite easy. It's 20. So I know that that's going to go at the end. And I know if I can work out the gradient, I can say what I need to multiply this by. Yeah, because remember the equation of straight line is just y equals mx plus c. The gradient is m and c is the intercept. So I already know c. I've worked that out here. That's what that is. Okay, I need to get the gradient. Remember, instead of y here, I'm calling that h, and instead of x, I'm calling that t. All right, so instead of the y, we've called that h because it makes more sense for height, and instead of x, we've called that t because it makes sense for the time. The constant c is 20. We've worked that out. Okay, so back to our pen. Let's just draw ourselves a nice triangle. I'm not so good at straight lines on here, but we can see what's going on there. So I've got my triangle. I need to know what the rise is. Okay, the rise going up. Let's just come back. So there's my rise there, and I need to know what my run is as well. So my run there, my rise there. All right, choose any 2 points on the graph. That's fine. All right, big space means you're generally more accurate. So what have I got here? My rise. I go up from 60 to 160. So my rise has been 100. And my run has gone from 10 to 35. Do you see that that's 35 there? Because it's halfway between the 30 and the 40. So it's gone from 10 to 35. Well, that then is 25, isn't it? Rise is 100. Run is 25. How many times does 25 go into 100? Hopefully you can see, but if not, use your calculator. It's 4. 4 lots of 25 is 100. So my equation, I can now say quite nicely, my equation, okay, h, just taking the place of y, is the gradient times x, but we know that this time we're writing t instead of that. Okay, let's just scrub that because I'm writing the wrong thing. Let's do it properly. H, I didn't write the gradient there, did I? Hopefully you were about to shout, no, you're doing it wrong. Is 4 times t. Y equals the gradient times x plus the intercept. It was the intercept that was 20, wasn't it? That is my equation, and we're done. All right, we got the intercept, read it off, and we got the gradient by looking at the run here and the rise here. Okay, that's the first part. There's a little bit more coming. So it says to increase his chances of winning, he also planted another sunflower. And the height of this second sunflower is given by h equals 30t. 3t plus 30 rather. H is 3t plus 30. We've got to find the day the two sunflowers are the same height. Well, that's when the two graphs would cross, isn't it? If I were to draw the graph on here, where they cross would tell me. But actually, I can do this better now using algebra, because I've got this second equation that's telling me that for the second sunflower, h would be 3t plus 30. And just as we saw with the other ones, the h would be the same where they have the same height. They've got the same height. So it means that these two expressions must equal each other. 4t plus 20 must be the same as 3t plus 30. What are we going to deal with here? We've got a number of t's on both sides. We've got 3t here. We've got 4t here. Let's get rid of this then because it's smaller. Let's get rid of the 3t. So if I bring in my pen again, let's take away the 3t. The 4t, take away a 3t, will just leave me one lot of t. I've still got my plus 20. And on the other side, the 3t has all disappeared, hasn't it? And just left me with the 30. I've taken the 3t away. What's the last thing I did? I had a 20. take 20 will get me back to, nice, just what t is, won't it? So t is 10. 10 days, put the units, don't forget the units here, it's important. After 10 days, they'd both be the same height. Okay? We want to know the height that they'd have as well. That's what it's saying down at the bottom here, isn't it? Okay, so we've worked out the day. We've done that bit. Now it's saying find the height of the sunflowers on that day. So let's find the height. Well, we can do that because we've worked out the days. We can just use one of these formulas. Yeah, we could use this one, or we could use this one to work out what the height is. Probably the second one, smaller numbers. Well, we could do less times by less in terms of multiplying by t. So we've got 3 times the t value, which we've said is 10. And we add on that second equation, 30. 3 times 10, 30. Add on 30. It's telling us it'd be 60. Okay, so remember the units as well. That height was in centimetres. So we got 10 days and 60 centimetres. Can we see from the graph that would have been the case? Well, actually, once we got the 10 days, we probably can, because you can read it off, can't you? 10 days you can see is 60. All right, but we used our equation so we could be absolutely sure. And again, if we'd use 4t plus 20, 4 times 10, 40, plus 20 gives us the 60 again. Okay, hope that's helped. It's just about writing these two things equal to each other and working from there. Okay, have a look at the exercise that's coming up.